Welcome to Romania. My name is Thomas Reukman from Utrecht University in the Netherlands. I'm the coordinator of the project ROMEO, Romanian Methane Emissions from Oil and Gas. We will be here in Romania to study the emissions of methane from the oil and gas industry. We want to find out what are the processes that control the loss of gas from these installations to the atmosphere. And with the results, we want to advise policy and industry how they can best reduce these emissions in order to reach the goals of the Paris Climate Agreement.
Greenhouse gases contribute to global warming and climate change. Methane is one of the most important greenhouse gases after carbon dioxide. The total volume of methane in the atmosphere is smaller than carbon dioxide, but its warming potential is more than 25 times higher. If you consider a 20-year time horizon, it's even 84 times higher. Methane originates from various sources like landfills, agriculture and oil and gas production. Romania has a long tradition in oil and gas production and reports high methane emissions to the European Union. That makes Romanian oil and gas production facilities an ideal study area for scientists, aiming for a long-term reduction of this important greenhouse gas.
And so Romania is a great opportunity because we can have many different methods and approaches at the same time. And we can start then building sort of this catalog of what the infrastructure looks like and what the different sources of emissions can be. So even, we can talk about the consequences or implications of the project here in Romania, but even more importantly, I think a lot of what we're going to learn here will apply to our understanding of the emissions globally.
Methane is invisible to the naked eye. It's colorless, odorless and tasteless. To measure the gas, scientists rely on advanced instruments. During the ROMEO campaign, they used high-precision laser-based instruments. These were mounted in cars, trucks, small backpacks, even on drones and airplanes.
Welcome in the measurement truck. Here you see our equipment. There's multiple instruments. The most important one is in the back over there. That's the machine where we measure the methane. It takes the air from this tube upstairs, brings it into an optical cell. There a laser is shot into the cell and bounces back and forth. And the methane actually absorbs part of that light. So the more absorption you see, the higher the concentration is. We do that with 2 measurements per second. So while we drive, we can actually see a source in terms of a plume that we pass through.
A plume of methane is in principle the same as a plume from a chimney, but you cannot see it with your eyes. One way to quantify the emission of methane from the concentration measurements in the plume is to release another molecule called a tracer from the same location at a known rate and compare the plumes of methane to the ones of the known molecule. Tracer gases are released with a known flow rate at the facilities where we have identified methane emissions.
This is when we go in and we place the tracer gas, release bottles in these areas. Then we go off-site, we identify the plume, and then we traverse the plume 10 to 15 times. The more times you traverse the plume, the less variability you will have in the end on your quantification. And based on this, then we can calculate an average methane emission rate and also give some uncertainty to the number that we provide.
However, not all methane sources are easily accessible by car or truck. When there are no roads upwind and downwind at the necessary distance to the source, there's an even more mobile solution: a backpack.
These instruments give you the mobility to go somewhere where a car cannot go. So this mobility can give you this opportunity to really pinpoint the source. You can do a hike with this one, but it gives you the methane concentration over the tracks you're walking.
Once a site with a high methane emission level has been found, specialists can detect where precisely the leaks are and how big they are. Then the leaks can be fixed and emissions of this strong greenhouse gas methane are reduced.
First we measure with the infrared camera. We make movies of the leaks. Then we quantify it with another device, a TVA. It's a toxic vapor analyzer. After that we make a proper measurement with the high flow sampler. These tags tell us exactly what's leaking. So example, this flange is leaking.
It tells us the ppm value of which it's leaking and the date it's measured. It's also easier for the repair teams to find these leaks, so it's obviously very bright, so they can find it easily and repair it.
These fixes are not only beneficial for the environment, but there's also an economic benefit. By using appropriate measures, such as fixing leaks and capturing methane from cold venting, it is possible to save 40% of emissions with zero net costs. Another platform that was used is remote-controlled drones. Scientific drones can't carry the heavy instruments used in the truck, but with some ingenuity, they prove to be able to sample the air coming from the oil and gas facilities. The advantage of using drones is that they can fly vertical patterns inside and outside the plumes, adding an extra dimension in measuring.
This air core collects air sample, and then later when we analyze it on our gas analyzer, based on GPS coordinates from the drone, latitude and longitude, we can exactly say where we catch the plume. We basically put it under the drone, and then the air is slowly pushed with a pump inside the coil, and after the coil is filled, we land, and after the landing we put coil on the instrument, and basically the sample inside is analyzed in reverse, because the last point that we collected will be the first point analyzed on the analyzer.
To get an overview of methane emissions from a large area, you need to perform lots of measurements. That might prove impractical or sometimes even impossible due to conditions in the terrain. Fortunately, highly sensitive instruments mounted in aircraft can provide additional insight into emissions in combination with ground-based measurement.
The idea behind this campaign is to compare, in particular, methane emissions estimates that you get by extrapolating your measurements that you take on the ground of these individual sites with the large overall picture that we can see with the aircraft. There are inlets under the wing of the aircraft which suck air in from outside, bring it through the wing in some tubing and into the aircraft cabin, which is where the scientific instruments are all strapped in safely in the luggage compartment. We can fly around large regions or whatever the scientific study area is and measure the methane, CO2, and water concentrations in that area. So if you've got an area emitting methane, you've got some wind blowing through that area, you want to fly upwind to see what's coming into the box, and then you want to fly downwind to see what concentrations of methane are coming out of the box. So if you subtract what's going in from what's going out, you can get the total of actually what was emitted within that box. And so we can cover really large areas and get a good picture of all of the methane coming out of that.
But how to be sure that the measured methane is coming from the sources we think they do? There are different sources of methane emission next to oil and gas production, for example agricultural ones. How to distinguish between them? Here isotopes can help.
So my role is not about pure quantification, but characterization of methane in this campaign. Depending on the process methane is produced, it will have different isotopic signatures. And by measuring this isotopic signature, we know through which process this methane was emitted. From oil and gas facilities, it will be very different than from a cow, for example.
All these measurements together are necessary to get a complete picture of the amount of methane emissions from the oil and gas production activities in Romania. The results are important to check whether the emissions of greenhouse gases that are reported by governments are correct.
Emission inventories are the basis for negotiations. That is why countries will negotiate on the basis of emission inventories how much to reduce their greenhouse gases. Emission inventories are also really important because they will compile all sources. So it's not only methane from oil and gas, also landfills, agriculture, everything is there. And from that you can decide which sources are the biggest in your particular country and where you should spend your money to reduce greenhouse gas emissions. But these inventories need to be underpinned by measurements, and that's why campaigns like this are so important.
The ROMEO campaign is the first large-scale investigation of methane emissions in Romania, and the results will help to reduce the emission of this greenhouse gas.